Okay, we need to discuss a few items in mounting. When you're going to mount an antenna on the boat, there are some concerns you have to take into. Let's talk about why we have the concerns, and then we can talk about how you're going to try to mitigate those as much as possible. On antenna, and I'm just going to use a line, this is an antenna. If we look at this antenna, there are some areas that come off of here that are commonly a part of this pattern. And this pattern that we've been looking at here, so this thing, has sections in it that go out to whatever the length of the frequency determines. If we're looking in the VHF area, that's typically the 150 meg area, we call that 2 meters. And as 2 meters, we basically have, let's say roughly 6 feet for one wavelength. Okay, and that one wavelength is that sign of what's coming out here for energy. So when we look at this one wave, this is what's called the near field. The near field is an extremely important area of this antenna for this antenna in its structure to become the tuned resonance point we need for this frequency. If we don't have it, this antenna isn't going to work very well. Further out after this, and out to 3 wavelengths, at 3 wavelengths, we start into what's called the far field. What's out there isn't real important. It is if you don't want to have a black spot or a blind spot in your pattern, but it doesn't affect the antenna. If you have a big metal smokestack sitting over here that's more than 3 wavelengths away, it won't be a huge impact on the antenna, only in the pattern getting out. However, in here, our first quarter wave is the most affected area that it can be in here. Every antenna is going to have this. This is a physics function of an antenna. The way you get that is 900 megahertz is 1/3 of a meter in length. Okay, so that makes the wavelength about 14 inches, which means a quarter wave of that is about, what, 3.8?
Okay.
Okay, so on this, it's roughly 18 inches.
For VHF.
For VHF. So in this 18-inch area, if we put anything in there that is conductive, or even worse, another antenna that has tuned functions, this antenna is going to see massive reflected energies. If we put anything in here, the energy that this sine wave is trying to pump into this antenna, when we put something in here, is going to hit that and reflect. And when it reflects, it does a couple of things. One is the energy does not continue out. It creates a thing called VSWR, which is a voltage standing wave ratio, is what we put at the end. But this builds a standing wave. So this piece that's sitting here and solid, and we can call that a couple of things. Let's say we mounted this antenna and there's a tuna tower strut, okay, that's running up close to this antenna. This antenna has effectively been detuned considerably. Its VSWR, when we build an antenna, we are always less than 1.5 to 1. Okay, and if we're center tuned on here, we're typically down at around 1.2 to 1. We can run this right up to 8 to 1 by putting that tuna tower here. This antenna's reflected energy is going to be equivalent to what's getting off of it. which means we have cut the antenna probably by about 75% of what it can do. It is going to affect transmission more than it's going to affect reception. So if you find out you have an antenna installed on a boat that you seem to be receiving okay, but you can't transmit, look for this. Something's sitting in there. This same thing, not quite exactly the same function, occurs if we mount two antennas too close together. When we're looking at VHF, the optimum, the best you could do is mount them 3 wavelengths apart. That's 18 feet. Very hard to do on a lot of boats. If we can't do it, there should be an absolute minimum of 4 feet between two VHF antennas. One of the things that happens is this antenna, let's say that this is going to be our active antenna. We're going to use it. This antenna is just mounted there because it's hooked to our secondary radio that's not even turned on. When this antenna goes to transmit, this antenna is going to suck that energy right out of the air. It's a tuned function. It says, I want that energy. That's what I'm made to do. And when it does that, we're going to severely limit how well this antenna can work. If this 4 feet becomes 2 feet, we're now down close to that first piece of the near field. Neither antenna will work. So if you take antennas and mount them too close together, you will kill all of the antenna action. These things have to have space, and without it, one of the easiest ways to tell is you put a VSWR meter onto your boat's transmitter. You'll see it real quick. If you're not seeing that 1.5 to 1 kind of figure or less, you have something in its pattern. Taking a look at some of the types of mounting people do, and I've seen this in marinas. If I take a look at a boat like this, and that's a radar arch. I'm not an artist. I've seen multiple VHF antennas mounted like this, 8-foot, 16-foot type antennas. Do not do that. Those antennas are a foot apart, they can't work. If you're going to have 2 large antennas like that, put one on each side of the boat. They need to be at least 4 feet apart. The other type of mount that I see is on a larger boat. We end up having this cover up over the fly bridge. And this cover can be, let's say it's 8 feet by 8 feet. Sounds like it ought to be plenty big enough. It's big enough if you're going to mount a lower gain antenna and you mount them like this. However, even at 8 feet by 8 feet, if you were to mount 4 of our 10 dB antennas in this kind of a pattern, each of these antennas is going to do a very poor job. Even though it looks perfect, you've got more than 4 feet, we're talking 10 dB antennas. Even though we're further out than our first wavelength and we're outside the near field, these antennas have reshaped the near field and stretched it out enough that they will interact with each other. You put up 4 antennas like this, you're going to have problems. Change these antennas out to something with lower gain and still mount them at distances. Don't mount another VHF item inside here. You could mount a cellular antenna, you could mount something else, but the VHF antennas on this type of a system, I would allow only 2, even though the customer may want more. If he does, you need to look for another place to put them. The other thing that could be done here, if the customer really wants symmetry of this top with 4 antennas, is to take these spots that we nixed out of there on 16 footers and put an 8-foot antenna on an 8-foot extender. The 4 antennas would all look the same, but they won't cause the problems that the 4 16-footers will cause. Okay, and last but not least, that's our radar arch. We're going to mount an antenna on the boat, mount it vertical, just straight up vertical. Everything that we do in VHF Marine has vertical polarization. That's where the antenna works. If you turn it away from there by even 30 degrees or so, you will not only lose all the gain that you could have achieved with the antenna, but you will also make the antenna totally ineffective. So an antenna that the customer wants, that says he wants to look like that because it looks neat, just tell him you'll have it in there and it'll be looking neat, but it won't work. Other than that, do this. This is no go. Hi, thank you for having listened to any of my little tutorials here. I was trying to keep them pretty basic. We intend to do some more involved tutorials in the near future. And I would be happy to answer any questions that you have. If you can send them in, please send them to support@digitalantenna.com. And again, signing off, this is Dr. John Jones, and my PhD is in electrical engineering and physics. Thank you.